So if this is a 0, if you know this is a 0, which it tells you this is a 0, then you know that this factor exists, x minus 5i, which is just that, and his buddy, x minus negative 5i. Now, negative 5i is the conjugate to 5i. And I wrote it this way so you guys can see that I still have x minus on both of them. Okay, because the fundamental theorem of algebra says that you can rewrite any polynomial function as a product of binomial factors, like this. Okay, but the crazy part is when you multiply these. What is x times x? What is x times... can we change the signs on these? What is x times 5i? 5ix, right? And then what is negative 5i times x? Negative 5ix. Stop being weird. Okay, and then we have negative 5 times negative 5, or positive 5, which is negative 25, right? And then we have I times I, which is I squared. I squared is negative 1. Negative 1 times negative 25 is positive 25. These cancel out. I am left with x squared plus 25.
So the 0 are plus or minus 5. What?
Yeah. No, zeros are plus or minus 5i. Okay.
Oh, yeah.
Now, for this problem, number 47, what you're supposed to do next, after you find this factor, the one with real numbers, is you're supposed to divide it out of this. That's how you can use the given 0 to find all zeros.
Ew.
So you're going to take this and divide it by this, and then find the remaining zeros. Okay?
Wow.
Now that part we've kind of already touched on. The part I really want you guys to see here is that when you have an imaginary 0, he exists, this binomial exists, and his buddy with the binomial exists. Okay? But what does it look like when you have something like this guy? This guy's pretty ugly.
It is.
You have x plus 1 minus square root of 3i. And you have x, not plus, stupid, not plus, x minus. Sorry, my bad. You said my bad, shut up. Okay, so x minus that, and you have x minus the conjugate. What's the conjugate? Just change the sign of the square root. So it's plus square root of 3i. Whew. Now, multiplying that, ooh, that's a game right there. You guys ready? All right, x times x. What do you get? X squared. X times that nasty thing is going to be negative nasty thing. 1 minus or plus square root of 3i. Oh, wait, there's the x right there. Right? X times this will give me this. Yay, yay. Okay, next one. Nasty thing times that. So we have another negative. That's negative 1 minus square root of 3i times x. That's this times this, right? And then we have the last one, nasty dude times other nasty dude. So that's going to be positive because a negative times a negative is positive. And then I'm going to take an extreme shortcut here that I hope you guys can keep up with. Because these are conjugates, I know what happens when I multiply conjugates. I get the square root of the first term minus the square of the second term. You guys know what rad 3 times rad 3 is?
No.
It's rad 9. And what's the square root of rad 9? Or, what is rad 9? Oh, I'm moving too fast for you guys. You guys are dumbfounded. Okay, what is rad 3 times rad 3? It is rad 9. And then what is the square root of 9? 3. So we have 3. And what is I times I? I squared. So that's actually negative 1, huh?
Oh,
So negative 1. Negative 1 times negative 3 is positive 3. So we have 1 plus 3 is 4.
Please stop.
Okay, let's pause for a sec. Okay, here we go. Now I'm going to make this negative go onto this x and distribute it into this. So I get negative x positive x times square root of 3i. That's kind of nasty looking. And then when I multiply this out, we'll make that a negative also, so we can keep the negatives. So we have to do multiple steps. Anyways, negative x, and then when I multiply it times that, it's going to be negative x square root of 3i. Now, cool stuff is going to happen now because we're not supposed to have any more imaginary numbers after we finish multiplying this. And look at this. What happens when I do add those together?
They get murdered.
Oh, yeah. Peace out. Woo, they died. Okay, so now I have x squared minus 2x plus 4. Wow, look how pretty that is
Isn't
now.
that fantastic?
I love
Yeah, it's way prettier. Okay, so you're supposed to take this and divide this by it.
Oh.
So you go this divided by that. Yeah, I said it wrong the first time. This divided by that. That's how you're going to find the other zeros. But that's a lot of stuff, huh? Just getting rid of the reals was a huge task.